Question number 3 is very similar to question number 2. In fact, so similar that we're going to use some of these steps, and then we're going to talk about how to make sure we understand what the equation can tell us. So we'll start again just by reading the question. We have a $1,500 investment, 12% interest, compounded monthly. So remember in the previous question we saw the word compounded, we substituted the word divided. I'm going to do the same thing here. Compounded means that the percentage is going to be divided into monthly payments. So I need to think about what that means. My 12% annual interest is supposed to cover my whole year, but monthly, there are 12 months in a year, so this means that my 12% is going to be divided into 12 payments. Because again, there are 12 months per year. So I'm going to follow my steps, and I'm going to figure out what that means for my percentage, which means I can get my multiplier. They told me that my original percentage was 12%. So 12% divided into 12 payments is going to be 1% per payment. So that is my per payment number. And I'll just keep labeling it so that way I know what this means. 1% per payment. Now I have to convert that percentage to the multiplier that I'm going to use. And to do that, we'll follow the same steps that we did before. That's 100% of the money to start with, plus the 1% per payment that they're going to give me, which is 101%. Remember, to convert that to a multiplier, we have to take our current decimal point, which is after the last one, and move it 1, 2 places to the left. So converting it gives me 1.01. That is my multiplier. Now I have enough information to build my equation, because they gave me the initial value in the original question, and now I know the multiplier. So I can build my equation as y equals 1,500 initially times 1.01 to the power of x. Now, if you want to, you can put a number next to x to remind you about how many payments there are going to be. So some people will call the answer 12x to remind themselves that there are going to be 12 payments per year. Some people don't write the 12 and they just remember to do it in their head, so I'll leave that up to you. If you want to write the 12, you can, and if you don't want to write the 12, you don't have to. It's kind of an optional step. Now, to use the equation for part B is why we end up bothering. In case you're wondering why we need such fancy equations, it's because if you want to figure out a long-term investment, like 25 years, it can be really tedious to figure out how many payments that's going to be, figure out each percentage payment, add them all up. That's why the equation is so helpful. It's because now we have something to plug the 25 into. 25 is basically the x. So the first thing we can do is figure out how many payments that is. We can figure out what the power is going to be. Or we can just plug it all in and let the calculator do it. So I'll show you both ways. If you wanted to first figure out how many payments you're going to get in 25 years, remember you're getting monthly payments, that's 12 payments per year times 25 years. That would be 300 payments. I'm just writing this down so you can see it, but that means that my equation is going to be 1,500 times 1.01 to the power of 300 payments. That's $29,682 and about 70 cents. Now, if I didn't want to do that 300 payment calculation, watch as your calculator can actually handle this all at once. If you have a calculator, especially that has parentheses buttons, you could do in parentheses 12 payments a year times 25 years all in one, and basically type the original equation exactly as you see it, and notice the calculator would give you the exact same answer. So you can kind of type it whichever way suits the calculator you have. It just sort of depends on what access you have and what your screen looks like. So either way, it looks like we'll have $29,682.70. If you round a little differently, that's no big deal. It's just a matter of making sure that you understand where that number came from and why. So take some time, let that idea sink in a little bit, and then you can try question number 4, the last video.